Good morning, everyone. Welcome to this first Industry Sector of the Month workshop. So this first session, we're trying this new series with the first session about environment, weather, climate. So it's organized by CASTIEL 2 or Package 4. For information, the presentations will be recorded. Before we start with the presentations and discussions themselves, just to give you some context, why this Industry Sector of the Month workshop series? It's because we started with you, the NCCs, to prepare a common industry use cases portfolio that I'm sharing on my screen right now. So with this industry use case portfolio, we aim to have a common set of industry use cases per sector. And using that, we noticed that we had several industry use cases sectors for the environment, climate, weather specific sector. Therefore, we decided to start this series of workshops on this topic. And for information, given the interest for this topic, we might actually have our second session also on this environment, climate, weather topic, because we noticed several volunteers propositions from other NCCs. Before starting the discussions again, allow me to launch a live poll. So I'm doing it right now. Up. So normally on your screen on the Zoom interface, you should see now some short questions just to let us know which next industry sector you would be interested in that we take for our discussions in this industry working group. So it's just to select the industry sectors that you are interested in, and if you would be volunteer for your NCC to present, or if you have any other question, feedback on this topic. I will leave the poll open during the whole workshop. So please provide your input on this so that we could really customize this series to our your best interest and so that it's relevant for you. Okay, now enough of me speaking. Today we will have a 1 hour 30 workshop. And it will be about, so we will have presentations around 15 minutes per speaker. We will start with NCC Czech Republic with Thomas Karasek. Then we'll hear from NCC Turkey with Merve Dermitas. Then we will have a presentation from a Siri. We are very happy to have Siri Easy Ways, the Siri Easy Ways with Mario Acosta, who will present also how they deal with interaction with industry or other target groups in this specific sector of environment, weather, climate. And then we'll have the feedback, sharing of experience from NCC Sweden with Torvik Feld and from NCC France with Marie-Sophie Cabot. So Thomas Karasek, if you are ready, I will stop sharing my screen and you could start sharing and present. You have 15 minutes.
Okay, thank you. I'm ready, and I suppose I'm sharing right now?
Yes, perfect.
Okay, so my topic today is basically regarding energy industry and basically the environment, as I will explain later what is the connection between these two. But first, I would like to start with the approach we applied in our NCC, and we are trying to push it forward for our collaboration with the industries. So on the left side, you can see the stakeholders, which are not only the companies but also the European digital innovation hubs, innovation centers, clusters, etc. Because those players, they have a pretty good picture of their ecosystem. So in Czech Republic, in most of the municipalities, there is an innovation center. We have 5 European digital innovation hubs in the Czech Republic. So basically, these are providing us very useful information about the companies and mainly SMEs in their ecosystem and in their network. So how the whole process works? We have the business development team or one guy who is basically actively identifying the companies who could be a potential candidates for the collaboration with the NCC or in need of use of digital technologies or HPC in general. So he is in touch with the companies, he is in the touch with the innovation centers, and when he identifies the company and contacts the company and they agree that the company has certain needs, he immediately contact the experts from different domains, and the first meeting is set up. And basically, when the experts are meeting with the companies, they discuss the topic of the collaboration, and they also discuss what is the best scheme under which the collaboration will continue. So basically, on the right side, you can see that it could go directly to the NCC or directly to the European Digital Innovation Hub, or for other means of collaboration like a contracted research or the collaborative research on the different grant schemes like a Fortissimo or others. Basically, our approach or our services which we could offer to the companies really depends on the maturity of the company, not only in terms of the HPC, but also in terms of the digital technologies. So basically, on the top of the pyramid, you have the HPC experts who are familiar with the HPC, and they may be using the HPC or cloud services. And on the bottom, you have the companies who needs the digitalization. They know nothing about the use of AI or numerical modeling and simulations. And basically, those on this bottom, these are mainly the target of the NCC. So we are trying to work with them and basically upgrade them through this pyramid to be more mature in the use of the HPC. And this is the system or the workflow which I believe could work, and we have several examples that it works. The case I will be presenting is basically good example of this. The company was contacted by our expert. This contact came from our personal network, and when we first meet, we basically discuss with them what is the problem that they would like to solve, and then we propose the solution, which I will share with you in a minute. So what is the problem? It's the SME which is basically developing the solution for the power plants or heat production plants, and they are basically offering the whole solution to create the whole solution for those who operate those power plants, and their solution is to put the catalysts into the exhaust pipe. You can imagine it as exhaust pipe to reduce the oxide and dioxides, which must be kept under the certain limit to be safe. So you can see on this small picture that there could be one catalytic layer, two catalytic layers, or three layers, and there are other things that basically the velocity profile of the exhaust gases should be uniform, because if they are not uniform, like on this yellow picture, they will basically burn out the certain portion of the catalyst, and the rest will be unused, which means that this catalyst layer must be replaced much sooner than optimal, which means it's more costly for the operator. This company is basically bidding amongst other companies to sell their solution to the customer, and for the purpose of creating the quotation for the bid for the customer, they need very quick solution or a very quick answer to the question, how many catalyst layer I will need for this particular installation? Do I need some homogenizer or not? So basically, they don't have a time to do the full development, to run the costly CFD simulations and get the answer after 1 or 2 months to be able to create the quotation for the company. So they approach us whether it would be possible to create some simple tool which will help them to do the quotation with high fidelity, because if the tool gives them the wrong answers, it's not used for them. So basically, we were discussing with them, and we said, okay, let's go for the surrogate models, which are quite effective. And the advantage of the surrogate model is that it's a simplified model, which gives you quite accurate results, and they are really fast. Their requirement is that they need a lot of data upfront to be created, and from those data you will create some surrogate model. You can use many things, many algorithms, polynomial surrogate models, kriging, or you can use the artificial neural networks. So we basically discussed with the company, and we said, okay, these are the steps which must be done, and it will take I don't know 1 or 2 years to finish a surrogate model, and we need those informations, those inputs, and we will be able to provide you such outputs. And when we were discussing with the company, the first problem which arose was how accurately current state-of-the-art softwares are able to capture the chemical reactions which are basically happening at those catalyst layers. And this was unknown to us. It was unknown to the company. And as we did the review or research, it was unknown to many people who are working in this area. The generic answer is yes, it works, but nobody knows what inputs are necessary and basically how it works exactly. So we agreed with the company that we will check this out. We will do kind of the proof of the concept, whether the commercial not commercial codes, but the state-of-the-art codes are able to capture these chemical reactions correctly. We did a survey among several codes, and we find out that the commercial code ANSYS Fluent is able to perform such as simulations. So basically, that was the output of the proof of the concept with the company. We said, okay, it works. So now we have to take other steps, but in general, it could be done. Out of this proof of the concept, we published a success story and the white paper, which describes how the chemical reaction could be included in the CFD simulations in the ANSYS Fluent, and it's available on our webpage. After this, we basically discussed with the company the next steps, And since it was expected that it would take quite some time to finish the whole job and create the surrogate model or digital twin, as you wish, we were searching for the sources of the funding, which we did again as a service of the our NCC, and we identified one possible grant scheme by the national grant schemes of the Ministry of Trade of the Industry. So we applied with the company for the grant, and it was successful, and we basically run this project for the 18 months. It's already concluded, and company received the software from us. So what was the subsequent project about? It was basically using the AI to create the surrogate model, which will help company to do the quick check whether the proposed solution for this particular installation would work, or how they should design this installation and their solution. On the right side, you can see that there is a different shapes. So for all those different shapes, for all different sizes, all different composition of the exhaust gases, all the velocities, there was many parameters. So we had a lot of synthetic data from the CFD to train our neural networks. So basically, we used the AI in the energy sector to create the tool which helps company basically speed up their first step of the design process, and basically are able to bid for the tender by the big companies. So that's in the nutshell what was our work in this particular project. It was combination of the activities as a NCC and subsequently activities of the IT for Innovations as a research institute. And with this, I will conclude my presentation, and I'm ready for your questions.
Now, let's continue with NCC Turkey, so with Merve. So we can see your screen.
Yeah, I guess. Can you see me? My
can
screen.
See you,
okay. Is there any problem?
Everything okay.
Okay. Hi, everybody. My name is Merve Demirtaş. I am responsible for the industry services of the NCC Turkey. Today, I am going to talk about the industry collaboration of the NCC Turkey in the sector of environment, climate, and weather, by giving some example of our proof of concept study carried with this with the SMEs in these sectors. As a country, we prioritize these sectors. We organize meetings to understand the needs of the SMEs from these sectors. But generally, we follow and apply our well-structured SME collaboration process. As a part of it, we utilize many networks. We first utilize our affiliated entities network, and they are big universities and residing in the big cities. They have already worked with the industry side, and also in their campuses, there are technoparks and many SMEs business located there. We also utilize the Truba network. Truba is the national biggest infrastructure in Turkey, and it has also services to the industry. In the first phase of the EuroCC project, we prepared forms, and they are available on our Indica platform. And any SME can fill out these forms by stating their problem and needs also. In addition to this, we use the TADEP channel, and we reach many SMEs in this way also, especially in the weather sector. TADEP is working under our mother institute and give funds to the innovative project of the SMEs. As a last way, we utilize our SME visits. These SME visits, we met many SMEs in these sectors also. Before talking about proof of concept study examples, I want to share with you our proof of concept study process. As according to our definition, this is a small scale project and taking 3 and 6 months according to the challenge. We can extend the time also. How the process starts: if an SME has HPC, HPDI, and AI related problem, we organize a meeting. In these meetings, we explain what is a EuroCC project, and we directed them to predefined questions. According to their answers, their problem or needs HPC suitable, we organize a second meeting. In these meetings, our NCC experts are available, and in these meetings also SME delivers a presentation regarding their problem and their needs. After this meeting, if necessary, I mean that if SME really needs the HPC expert or academic expert for the problem of them, we assign these experts, and after this process, company and experts, academic or HPC experts, fill out our proof of concept study application form. At this point, I want to mention that not all the problems turned into a proof of concept study. We have an evaluation process. According to our process, every affiliated entities give their points to the problem by considering a few of criteria. These criteria are following. Proof of concept study meets the goal of the EuroCC project scope. The other one is after the proof of concept study, we expect the company to reach the next HPC level. For example, before the proof of concept study, if the company is HPC user, we expect them to reach the HPC champion level after the proof of concept study. And also the other criteria is that the problem is really needs to HPC environment. By considering this criteria, every affiliated entity give their points to the problem. If the total points exceeds some threshold value, then the proof of concept study started. As NCC Turkey, we start the proof of concept study by providing them free HPC resources. This can be CPU or GPU, and we also provide free academic mentorship and free HPC expertise. Let's continue. NCC Turkey always monitor the process by requesting to update their interim reports. According to the interim reports, if HPC is used and there are some progress, then the project goes through the final stage. If there is no progress, we close the project. At the final stage, the company and experts complete the final report. According to their report, if the company workers gain some HPC related skills, or company gains some business benefits, maybe in terms of time, in terms of money and cost, then this proof of concept study turned into a success story, and then we share this success story through our social media channels in order to encourage the society. Up to now, considering the first phase of the EuroCC project and also second phase of the EuroCC project, we have totally 5 proof of concept study realized in the sector of environment and weather. 3 of them completed with success stories, and 2 of them are closed because we don't observe any progress. These can be results lack of agreements between company and experts, and enough time is not allocated by the company to complete the study. Now, I want to share with you one of our proof of concept study in the environment sector carried with ASA Metal. This company operates as SME and one of the leading manure management companies in the world. Company designs and manufactures scrapers, pumps, mixers, and filters. During the manufacturing process, a company utilizes the computational fluid dynamics simulations. The problem, actually, I want to mention that this company, before the proof of concept study, used the in-house computation systems. Let's discuss the problem. The problem of this proof of concept study is that company wants to manufacture more efficient pumps. These are used in the water treatment facilities, and they want to increase these they want to increase the mechanical and electrical efficiency of these pumps. With this aim, the company utilizes computational fluid dynamic simulations. During this proof of concept study, NCC Turkey helps the company by providing academic experts and free HPC resources. Academic experts helps the company to tackle with the problem in academical sites when they face an academical problem. And then the problem stages are defined. I do not talk about the details of them because of the limited time. In conclusion, regarding this POC, proof of concept study, a company gained HPC related skills and conducted simulations in HPC. And also they achieved to increase the 7% of the manufactured impeller. And also company states that by using HPC resources, their simulation time decreases considerably. In this study, due to the business benefits in terms of efficiency of the new manufactured impeller and also time, decreased time considerably, the results are shared as success story. The other proof of concept study I want to share with you is about the wind turbine rotor design. This proof of concept study realized by Momentum ARGE this company operates as SME and designs small and medium size wind turbines. Company obtains energy production from clean and sustainable resources. By doing so, they want to aim to contribute to the production of countries' natural resources. The problem of this study, the company utilizes the computational fluid dynamic simulation for aerobic performance prediction of the wind turbine rotors. They conduct their simulations by using Fluent program with their workstations, in-house systems. And also company wants to improve the CFD analysis by using OpenFOAM and SU2. As you know that these two programs are open source programs. But they do not use these programs before. Therefore, NCC Turkey assigned an academic expert to tackle this problem. NCC Turkey also provides free HPC resources. Company workers and academic expert construct the stages, and again, I skip of them. And we experienced some difficulties during the process. The engineers from the company not allocate enough time for the test cases. Therefore, no significant progress achieved, and NCC Turkey preferred to close the proof of concept study. Now, I want to complete my presentation with general remarks. These are the experiences of the NCC Turkey. Generally, companies are lack of HPC experience personnel. Hence, the initial learning process takes too much time. Therefore, NCCs will be patient at this point or at this stage. Moreover, you can offer tailor-made solutions for their varying needs on the HPC environment. After completing the proof of concept study, do not break down the relationship with the SMEs. You invite your training and workshops. In this way, you can ensure that they use HPC sustainably. In addition to this, you inform about them your HPC resources and encourage them to apply your HPC code for the sources. And also, timing should be flexible, especially for the manufacturing sector. The workers are busy in these sectors, and sometimes they cannot allocate enough time to finish their responsibilities during the proof of concept study. Therefore, NCC Turkey extend the time for the updates generally. One of my previous slides, I mentioned that we assign an academic mentor to the proof of concept study. Aligning the academic and industrial expectation is difficult, while the companies focus on the immediate outcomes, but while the academia expects intellectual outputs. Therefore, at this stage, NCC helps these relations to run smoothly and in a healthy way. And now this is the end of my presentations. Thanks for your listening.
Great, thanks, Merve. Very, very interesting. And let's now continue with the series Easy Ways and Mario Acosta. So now we will have a new viewpoint. So to change to shift from the NCC to the series. And let's see how, in the case of a Siri Easy Ways, how it goes for you to interact with industry on the environment, climate, weather topic. So you have around 15 minutes and the floor is yours.
Yeah, thank you for the presentation. I understand that you can see my slides.
Yes, full screen, perfect.
Okay, so thank you again for the opportunity also to be represented here. And well, in my case, I'm Mario Acosta. I'm coming from Barcelona Supercomputing Center and also the coordinator of this COE, which is we are trying to looking for this excellence in weather and climate simulation for our community. As you can imagine, we are super connected with academia in the activities in which we are involved, but at the same time also we have also some compromises with the EuroSPCGU community in general. So in this case, not only, for example, climate or weather modeling center, but also in general, we offer some services also for industry, and we have also connection and collaboration with vendor, SPC center, industry. And this is what I would like to summarize and overview here with all of you. Actually, also the presentation from the other SCC are super interesting. Just to introduce briefly before moving to the SPC services, in our case, even doing some, coming from these weather and climate communities, also we have a lot of needs from the HPC, and mainly this, mainly this is the reason why we are moving and we are applying and we have all this expertise also from the HPC perspective. To try to make possible this weather and climate simulation, this prediction for climate change, for example, we are working also with CFD. At the end, it's the same, it's the computational fluid dynamics models, and try to simulate this ocean atmosphere. And during the last year, we have increased the number of components needed to do these climate change studies. So this means that we are adding a lot of complexity at the end in this executable that we are running in the HPC supercomputers to make possible these studies. At the moment that we increase all this complexity, obviously also, and we aiming all the communities, so also including different companies that they are also interested in try to know more about these climate studies, for example, for winery or for the sales of in winters, about the clothes and this kind of stuff. So we collaborate also with these kind of companies, and all of them moving in these climate studies and this numerical model that we use for this. So as I say, complexity is one of the issues that we have for where we need all this HPC application moving for GPUs and this stuff. And the other one, probably the biggest one, is the resolution. So something that we proved in the past, in the recent years, is that try to do our climate study as this is an example, and now you are seeing a little bit about the clouding simulation. This is a real simulation with one of our couple model. To make this possible with a global resolution of 5 kilometers, we need like 300 nodes of -5 or LUMI, press scale machine, the YouTube video. So to make this possible, and we need almost 90 days, more or less, to produce the simulation that you are seeing now, with the visualization process. So as you can imagine, all these SPC services in which we are working are super important to offer also for the community to try to make possible this increase of the resolution in which we are working at. And this is where we are here, Easy Ways 3 and the Center of Excellence for this. In our case, this Easy Ways 3, the main goal is trying to support the weather and climate modeling community to achieve this scale supercomputing. So we are focusing now in the 3 scale machines and try to offer services for this specific one. But in any case, also we can work in any supercomputer below to academia, universities, companies. It doesn't matter. We are partners from different countries. We are working in different tasks. At the end, the most important is try to transfer and establish knowledge and technology for efficient and scalable simulation. So this brings achieve the best scalability in parallelization, I mean, possible for this weather and climate application. Then also close common technology gaps using different tools that we are developing and try to provide to the community via some development across this European community. And finally, also serve as a sustainable community hub for training, communication, and dissemination of all this work in SPC that we are doing for the community. So in this case, developing trainings, seminar, hackathon, and all this stuff. As this is an overview about all the activities in which we are involved. Actually on the left, you have our models and tools, and then the collaboration with, for example, some vendors, HPC Center at BSC in my case also, but we also with other HPC Center around Europe. And then moving to the right, we have the collaboration also with other COEs. Actually, we started also with NCC Italy, for example, or other scientific projects, for example, this One World or Climate Europe 2. And well, in general, now moving with other initiatives behind this Euro-SPCG umbrella to provide our services, our tools also for different user or communities. So this is our scope. And as an example, we have this one, where we have Destination Air. Maybe you know about this initiative, no, from the European Commission. And then around the Euro-SPCG, we have different, for example, projects on the left. As I said before, SPC centers, vendors, scientific projects, and we serve our community models, for example, for atmospherical or ocean prediction, and we try to transfer the expert knowledge from the real developers in the community and the tool that we are developing to a broader public. So in this case, we take all these work in which they are working to create HPC services that could be useful for other companies or users, or for training, for the creation of summer school, hackathon, and this stuff. And this is a summary, an overview about what I think that could be interesting, at least to know for the people attending this workshop. So we have some specific HPC services that they are free for the Euro HPC community, and we have different calls. We have like two different services. The first one, directly we work, so it's pretty similar that you saw before, no? So someone apply for this, interested in optimizing or scaling some of the weather and climate application. So in this case, we study this possible application, we evaluate is suitable for us or not, and we try to work with with these users, company or whoever who is applying, and try to solve these issues. On the right, you have different services that we are offering. For example, the reduced precision of the weather and climate application, also containerization for the model in which they are working, data compression, domain-specific languages. So we have a catalog, no, with this service catalog where we are offering different activities that the people that are applying, they can take. The service 2 is more about our tools. So also we have different tools. For example, these domain-specific languages that I was talking before, and we offer these tools so the institution apply for this can use it by themselves. No, we offer some support to use this tool. Then also we have a service portfolio where all the information related with the SPC services, the training session, the hackathon, summer school, everything is there available, so you can check it and try to understand more about these services that we are offering. Sorry. To give you an idea also as the previous presentation about the different services in which we are working now, here we have the first three that we, during the first call that we did last year, in which we are working. And the three of them are or air system, or either air system or atmospherical model or application. And in these cases, we are working in optimization for porting GPUs in this case, or just try to do some optimization for MPI, communication, OpenMP, and this kind of stuff. No, at the end is try to increase the throughput of this model, or try to adapt for new technologies. In this case, the GPUs of new supercomputer for application that were using only CPUs in the past. Now we have a second row of the call, and we are starting to work in other application. Again, we are talking about ocean, atmospheric, or air system application, and mainly our work as the community usually asks is the GPU porting, or also we have this ECR where we are going to reduce the precision of the variable from double to single, looking for increase the throughput of this model. So this is something that we have a tool, an automatic tool, to make possible this reduction of the precision of the variable, maintaining the accuracy of the model, no, of the application. That is super important in CPD. As I said before, no, as an overview about we offer, we are talking in service one about collaborative project between EasyWaste 3 expert or HPC expert and then the institution applying for this. And we try to offer some guidance, advice, and some engineering for this project during 6 months or 1 year. At the end, the main goal is try to improve the model performance, the efficiency, the scaling, some porting of the model, as I was talking before, no? For the specific computer infrastructure that the institution apply for this, they have. In service 2 is more focusing for the adoption of our tools. So in this case, we are developing different tools that everything is in this service portfolio that could be interesting for different institutions. They apply, and we provide this with some support. At the end, is pretty similar, the goal, no? So it's improve the model efficiency through this tool that we are offering to try to adapt for the computer infrastructure, also for press-scale machine, for example. So this is for the HPC services. As I said before, also, we offer for everyone for free different trainings around this HPC for weather and climate community. So we organize different hackathons. The next one is going to be in spring 2024. So actually it's open for application. We have also summer school. The next one in 2024 also is open for application. To try to understand more about the different trainings, we have a calendar, and you can know more about all that we are offering there, plus other events offering by other COEs. So all this information is there for HPC topics. And also we have training material and online courses, actually also in collaboration with CASTIEL too. Where we try to spread all these online trainings that we could do, and also the expertise that we can offer for the community. Yeah, as I said before, no, we have opened the second EasyWaste 3 hackathon, and also the summer school. So if you know someone that could be interesting, they can apply for free. For training online courses, for example, we have this kernel tunnel, which is to try to understand the performance on GPUs about CFD application. And actually, we are doing this in collaboration with NCC Austria. Then also we have activities in communication engagement with the dissemination. So we try to attend to different events or workshops. So here also we have another opportunity to try to exchange expertise and try to evaluate some possibilities for collaboration, no, with the EuroACC, with the other NCC, or with the industry, no. So we have several panels interesting for this, also from our community, no? You know, so in this case also there is a space for to try to find, no, other collaboration with you. Also, we organize workshop, and we have another one in 2026, in where we try to cover all the community there and try to find a space for discussion. And that's all from my side. So as just a brief summary, we have all different social media if you are interested to work with us in our HPC services, or to know more about the COEs. And well, also you can subscribe to the mailing list or the newsletter. So please keep in touch with us if you are interested. Thank you.
And now let's come back to NCCs and continue with NCC Sweden to hear from the experience on this sector, for this sector in NCC Sweden. Dr. The floor is yours.
Thank you very much. Good afternoon from Sweden. Okay, let me go full screen. Can you see it well?
Yes, full screen, perfect.
Okay, so I'm here to tell you about a proof of concept project we have been involved in, but two caveats to begin with. First of all, SLB Analyse. Our client here is not actually an SME. It's a group, it's a unit under the Stockholm municipality. But we consider them to be good end users, good clients for our services. And it's actually a trilateral collaboration between SLB Analyse, the Hidalgo COE, and ourselves. And secondly, second caveat is that I'm not really the right person to be presenting this. I'm not the industry champion, and I haven't been directly involved, but I'll try to do my best to give you a general picture of what this project has been about. So it all started through personal contacts, actually, with people at SLB Analyse, SLB. And they got interested in HPC. They were quite limited back then by their own on-prem servers in the basement. So the prospects of having access to HPC sounded very interesting. And then when the discussions continued between us, we realized that their use case was very relevant or related to what the good people at Hidalgo 2 have great expertise in. So we connected them, and everyone became rather happy about this collaboration. So we turned it into a proof of concept project. And it has two aspects. One is the first stage, in a way, is a wind comfort study, which is then followed by an urban air pollution study. So the first part, wind comfort, there you are interested in different wind profiles at flow inlet. Well, yes, as I mentioned, we helped them get access to the Meluxina EuroHPC system to begin with, and help them set up a test case and to run the OpenFOAM computational fluid dynamic software suite on Meluxina, and looked at the generation of the mesh for Stockholm City and fixed a few problems with the mesh. And we're still in touch over this collaboration. And in the second phase, the expertise and the tools from Hidalgo really came in as very important. They can add models on top of vanilla OpenFOAM simulations, if I understand correctly, to calculate the dispersion of aerosol particles. And their data was shared between SLB over some measurements of wind profiles and so on in Stockholm, and also the mesh of Stockholm City, the heights and width and shape of buildings and forests and bridges and whatever. They were shared with Hidalgo, who then applied their own workflows and models on top. This is currently ongoing. It's not finalized yet. The challenge has been the large and complex geometry of Stockholm. The goal is to cover a large area in sufficient detail in Stockholm City with sufficient resolution to cover, I mean, fine-grained effects related to the dispersion of particles, and to study the influence of terrain, irregular buildings, bridges, tunnels, etc. for the whole Stockholm area. That's the end goal. OpenFOAM, you might be familiar with it. It's an open source package to solve the 3D Navier-Stokes equation or equations, plus transport equations. Yes, that's where the pollutant modeling comes in. It uses finite volume methods on unstructured meshes, and it is very good for HPC because it shows great parallel efficiency. All right, they were actually using other software to begin with before we started our project, and OpenFOAM was a little bit of an unknown territory for them. So part of the journey has been to teach them a little bit about OpenFOAM. Let's see. Only a little flavor now of what the results are, nothing really quantitative, but here's an example of what the input data can look like. This is a height map of Stockholm City, not the whole city, but a part of it. Of course, zoomed out rather significantly. And here is now some initial results from the simulations showing this is from the wind comfort study performed by Hidalgo, where you can see the wind strength in different locations around buildings and so on. So that's really all I have to say, but I'm open to take any questions and hoping that I have some answers to them.
If there is no other question or comment, then thank you, Thor. And I think we can continue with NCC France, with Marie-Sophie Cabot.
I will share my screen. Okay. So I will just focus on on two cases that two POCs that we presented in the portfolio. And I'm sorry, I did not present how we work in NCC France with SME. We work mainly with B2B meetings that we have, especially with the startups in incubators and so on. We meet also SMEs at trade fairs, and we take part also in DIH, but some companies just join us by word of mouth. They contact us directly. I did not report a use case, but we also work with the air monitoring agency in our region. So when they have big computations to run, they come to us. The first use case I will present comes from Risk WeatherTech, which is a young company because it was created in 2019 with 3 persons who have competencies in climate modeling, in geographics, and in weather forecast. So this was performed during EuroCC1. They came with a project to produce, their project consisted in producing a statistically significant set of data for extreme weather events on France landscape. So to do that, they took they started from 354 storms, which were recorded by Météo France since the 80s. And they disturbed the storm 28 times for each storm, just 4 days before it touched the French coast. So this leads to about 10,000 realistic storms with a spatial resolution of 5 kilometers. So this improves the local knowledge of wind and storms on the French territories. I'm sorry for the previous speaker, but they are using a code which comes from the US National Center for Atmospheric Research. It's a WRF, and they also use a method which was developed for tropical cyclones, which is called SCEPS. They needed 870,000 CPU core hours on our machine. The next POC concerns water quality management, and the product engineer is they are a major consultancy agency because they were created in 1980, if I remember, and they are specialized in water management. This means water purification in the design and engineering studies for water management. So this concerns water purification systems and also drinking water distribution. And now they also have an activity on water management in a natural environment. So for a few years ago, with the project of the Olympic Games and the idea of having swim in natural rivers well, beside Paris. So they had a study to run in the river Marne. So they started with a 2D standard modeling of the flow, and they had a 3D fine modeling in one sector, which was concerned with baths, with swimming, and well, and yes, the problem comes for this was a command from j'aurais besoin d'aide, Marie-Françoise. La commande leur venait en fait des pouvoirs publics.
Okay, so it was a public authorities request.
Pour évaluer si ils seraient capables de prendre des mesures suffisamment rapidement en cas d'épisode de pollution bactériologique à partir d'un des points d'émission qui étaient suspectés.
Okay, so this was a request from the public authorities to support them in taking decisions after a pollution event to know how to manage the access to the river. So we'll see this in activity this summer with the Olympic Games indeed.
Okay, so they also needed some computing time, and they had a great benefits in using HPC instead of their own servers that they have inside their company.
Okay.
So thank you for your attention, and sorry, really sorry for my poor English.
No worries. Okay, thank you very much, Marie-Sophie, for this presentation of these two use cases from the French NCC. Also, I will give the floor just a couple of minutes to Guntram who has some announcement, a message for you on this specific topic, and then I will do the wrap-up.
Yeah, I was in contact with some of you regarding the establishment of first thematic application cluster, which I will present again here. So it was presented at the all-hands meeting in Slovakia, but not all of you were there. I will very briefly introduce the idea and then point out which steps we have already taken and what would be the next steps towards the first of these clusters, which is related to some presentations we have seen today. Let me share my screen. Share. Screen, go to. Okay, here we are. So the idea is to sort of group related COEs and NCCs to have a bigger impact for of these groups around certain topics. So that would allow a bundling of efforts and a better outreach to certain communities which are maybe not aware of what's out there, what are the possibilities of HPC, but which have sort of common or overlapping needs. So that would be the creation of focal points for certain types of applications. So what would happen exactly in these application clusters would sort of be open to, let's say, agreement among the partners of these clusters. So there are a lot of potential activities. I won't go through all of this in detail. We'll send you the slides after. This could be agreed on the by the members. So there, from what I have seen, at least looking at the COEs, there would be a number of, so maybe here are some potential benefits of it. Yeah, so for the COEs, they could gain more visibility for their tools, access to outside communities which they could not reach alone. NCCs would get maybe access to more solutions for their clients. So that could help to transfer technology from the COEs to potential clients, and the users, of course, would get just more a broader portfolio of potential applications there. Of course, we have to be careful not to touch it too much. So if we these classes are too fuzzy, it's not focused enough, and we would dilute our efforts. So we need to really see that the needs and offers and benefits overlap. And there would be, of course, a strong need for the members of these clusters to put in some effort for it to work. So so this is a list of potential clusters. It's certainly not complete. So one of the first clusters we thought of is sort of, let's say, modeling high societal risks which are induced by environmental effects like climate, weather, floodings, whatever. And because we have a couple of COEs working in this area, and also, as we have seen today, some NCCs who already have use cases there, and this was the idea to start with something to try out this idea. So here just some examples of what type of risks we are thinking of, but there are certainly more, like droughts and storms and whatever you can think of. Which would need to be modeled either to assess the risk or maybe to mitigate risk by building dams or avoiding climate change or whatever. So this was our first, let's say, our first focus here. So we presented this idea in general at the all hands meeting, and there was generally a positive feedback. Of course, then we have to start somewhere, and that's, as I said, the idea was to start with one cluster, and the idea was to start with environmental simulation and risk management, which is also fits well with at least some of what we've seen today from the NCC. So currently we are trying to setting up a kickoff with some interested parties, not maybe with 30 NCCs, but maybe with a few select ones who are very interested. So I'm currently in contact with Hidalgo. I was very interested to see that actually they worked with NCC Sweden on this particular use case. Maybe I can push them again a bit on this, because they were already active in exactly the right in the direction we had in mind. So after this meeting, I've seen that some of the use cases presented were okay, maybe some fit and maybe some did not directly fit, because they are more on engineering solutions to reduce pollution, which would not, in my view, not directly fit what I had in mind. So I invite you to think about if you would be interested in to contribute to such a cluster, and let me know. And so we can have a second try to kick off this cluster in the next couple of weeks, and to find out the overlapping interests and the mutual benefits that could arise from this cluster. So that's more or less the state of the activities.
Indeed. So thanks, Bertram, for presenting to everyone, so maybe people who could not be at the HM, what the thematic clusters are about, and to yes, again, promote our open call for volunteer interested people to join Guntram on this topic, on this action of thematic clusters, to try to launch first actions together on this topic, which would be also a way to collaborate with a series on this specific topic. So Guntram showed you what is proposed. Please contact him if you are volunteer to work on this topic. Otherwise, we are almost at the end of the slot for this workshop. So let me warmly thank the speakers. So thank you for Thomas, Merve, Mario, Thor, and Marie-Sophie. I hope I'm not forgetting anyone for presenting today. Let's see us together again for our next session with other speakers, probably on this topic or on another industry sector in the next months. And with that, I thank you for your participation and I wish you a nice rest of the day.